Yeah, why did you click broadcast?
Hi, organizers, please repeat. I didn't hear you well.
Hello, everyone. Good morning or afternoon, depending on you are. Before we start, I would like to do a quick audio check. So if you can hear me and see the screen, would you please write me a quick comment or a question or anything? Let us know. Cool. Thank you very much. So welcome again to the sixth episode of our mobile mapping webinar series. My name is Bishoy Gerges, and I'm here with my colleague, Miguel Parra, from the mobile mapping support team in Biberach, Germany. And we'll be presenting to you today data export to TMX and efficient feature extraction. We would like to start today with some recap on what we've seen before in the webinar series and our goal from this presentation, also the required level of knowledge that you should have until now. We'll also be going into the resources that we'll be using from software and data. And later we'll be showing you hands-on on data export from TBC into TMX format. And we will import that data into TMX and we'll start some feature extraction inside TMX software. The whole goal of this is to present to you some tools that might help you save time and effort and extract features more efficiently. Later on, we'll finish with a summary and then wrap up with questions and answers as every session. So let's start with the knowledge that you should have obtained until now. So you should be able until now to collect your data more efficiently, or you should know how to process your trajectory in PostBack and also make some smart decisions on the processing method. You should also be able to QA/QC your location, orientation, and the trajectory quality in PostBack before you move to the next step of loading your data inside TBC. Optionally, you should be able also from our previous webinars to register or colorize your point clouds and be ready for the data export that we will be discussing today. Today we'll be using the latest version of TBC 5.11. In addition to that, we'll be also using TMX Asset Modeler Standard or Pro. The features that we'll be having today will be available on both versions. In addition, we'll be using MX7 and MX9 missions, both of them to show you extraction techniques from both types of data and the corresponding TMX import template. And as usual, don't forget a mouse and keyboard and a good cup of coffee. So now I will let my colleague Miguel take the export part. So there we go.
Thank you, Bishop. Hello, everyone. Here is Miguel. Welcome from my side to the webinar of today. To start with, I will start the presentation with how do we export the data from our raw data format into a TMX format. So we could be able to import the data into TMX. And here I would like to mention two differences between MX7 and MX9. So in my screen, you will see that the mission or the data exported from MX7 will be mission-based, meaning that no run selection is applied. Another difference is like the data is always exported in geographic coordinates, meaning that no conversion is applied during the exportation. And another important remark is like even though you change or apply GeoI model, this is not taken into account while we exporting the data. Knowing that, let's move on to see the options that the data exporter offers to you. The data exporter allows you to export different formats, and today we are focused in the TMX exporter. The TMX exporter will ask you to select the data. Even though the selection is asked, you might note that now the data will be exported mission-based, so no run selection is applied. Another option that you need to input is the name of the file or the name of the folder containing your data and the location of this folder. Another important input or settings in the exporter if you are interested to save the location of each panorama file. So let's see in TBC how we can export a mission from MX7 data. Here in my screen of TBC, we have different runs for two runs for our MX7 data, and we'll start the exporter using the Home tab. In the mobile mapping option, we have different exporters, and if you see, I have selected already the M exporter to TMX. Already is selected one run But even though I select 2 or 1 run, this selection won't be applied during the exporter, meaning that the whole mission will export it. Once we move to the file name, we'll be asked to give a file name, meaning a folder name, and the location of the file. And last but not least, the configuration of the GPS attributes in the panorama files, if you are interested or not to store this information. Once we click the exporter, we can have the results done, and to save some time, I have already prepared some exported data from MX7. The MX7 will be stored in only one folder with the name that you give into the exporter. This folder will contain 2 information. One CVS file for the panorama containing the name of each image and the corresponding location. Another CVS file named as a trajectory containing the trajectory information of our mission and each individual JPEG file of the mission. So now let's move on to see the difference between MX9 data. In MX9 data, you will have the option to export either the entire mission or individual runs in that mission. Another difference is like you might be able to register, improving the accuracy of the runs, so you could control if you exported or not this trajectory information. And another important remark here is the ability to change the coordinate system, meaning that the conversion of the input data could be applied. Difference between the exporter for MX7 and MX9, we need to input the corresponding exporter and then select the data. Here, the first difference, we could select only one run or export the entire mission. Same as a MX7, we will be able to select and define a name for the export data and the location of the data. Another difference between the two systems is, or the two exporters, sorry, is that with MX7, with MX9, we could export the entire data set or a specific sensor data, meaning panoramas, or if I'm interested only in the point cloud. A remark here regarding the point cloud is like you could export either RGB information or the timestamps, which could be possible only in the current version of TBC. So let's see how we can do this into TBC. So now you see my screen of TBC, you will see a mission of MX7 and I will, MX9, and I will start the exportation same as MX7. Selecting the corresponding exporter, I will be asked to select multiple or the entire mission. So here I will be exported 3 runs. Same as a MX7, location and name, and if I'm interested to export all the runs, all the sensor data. Let me now move back to my presentation to see in detail the results of the exported data. So we will see a folder containing the laser data. This laser data will contain a LAS format for the point cloud and a text file with a reported information of the exportation. For the images, you will have an individual folder containing the JPEGs and the reference files containing the position of each image. And last but not least, you will find a trajectory file containing the information of the trajectory of the mission. With this data, we could move on into the TMX import, which will be explained by Bishoy.
All right, so once we have exported our data now into TMX format, it's time to import it into TMX software. To start the import of the data, as you have seen, we have moved from our proprietary formats into more open formats like the LAS files, CSV, and JPEG. And in order to import this into TMX, we will need a help from what we call a template to understand the structure of the imported data. The template simply tells TMX what type of data could be found where. For example, in your CSV file, which column corresponds to longitude and which column corresponds to latitude, which column has the time information, and in what convention the time is stored. All of this we could have inside the template. So the template is predefined and tells you exactly, or tells TMX where to save this information, making the template specific per system. However, we have templates for all of our MX7s, and we have templates for every MX9, meaning the templates for the MX9s are unique in case you have planar cameras. The reason for that is that we store in our templates for the MX9s the internal calibration parameters of the planar cameras. If you own already an MX7, you should have a TMX coming with a pre-loaded MX7 template. Another thing to note when we're moving from TBC into TMX universe is that the mission concept changes. So in before we had a mission that consists of multiple runs. However, when we move into TMX, we do one export. Everything consolidates into one run, or we call it TMX run. So whenever we are going to refer to a run from now on, it's going to be a TMX run, which was previously a TBC mission. Now let's have a quick look at how to import the data that we have just exported from TBC. So I have here TMX Asset Modeler Pro open, and I'll simply go to my procedures and I'll go to import run. You could choose your template based on the data type that we're importing, and it's going to be the equirectangular. This template basically works on the panoramic JPEGs. And then we will browse simply to a folder where we're going to save this, and I have already prepared the folder here. So let's just go to that folder and give our data a name. This data was collected in the city of Braunschweig here in Biberach. Okay, so here in Germany. So let me just write this again, and we can be good to go. The template, or sorry, the import takes you on a journey, on a wizard to choose multiple files while you're importing your data. The first step will be importing your trajectory. So I will simply go and choose the trajectory that I've just exported from TBC. And this will be the CSV file. Once the trajectory is validated and imported into TMX, the next step will be available for you. So we could go ahead and import our panoramas. The panorama CSV is just sitting next to your trajectory, and I will import it. And as you see, now my images appear inside TMX. I'll disable the OpenStreetMaps for smoother navigation for now. And don't forget at that step that you still have to move your images inside the newly created TMX run. So I will simply go here and prepare my folder to receive all of these images. I will copy them, I'll paste them in my new folder. And at this moment, you could just go ahead and fill any metadata that is necessary. Once you're done, the import is ready and we could immediately start the extraction from here. However, if you're interested in importing the MX9 run, the procedure is going to be a little bit longer because importing the point clouds will change a little bit and will take more time. To import a MX9 run, it's simply the same procedure: import run, choose the directory, and for the template, as you see, we don't have any yet. So I have already a prepared template for us for this webinar. And as you see, the template holds a serial number, which means it's system specific. I'll go here, pick my template, and my template will be added and is ready to be used now. I will skip this step, and I have already prepared the run for us, but the procedure is exactly the same. Now let's have a look at what we have done. So far, we have taken our trajectory CSV file, we converted that into an OVF during the data import, and it's saved inside the trajectory folder. We have also converted our last point clouds into a format called OPC, which is specific for TMX, and it's saved inside the point cloud folder. And then also we did the same for all of our images CSV files, which are saved inside the corresponding subfolders. And in addition, we have some important information that is saved inside the OMR file, which holds information that my colleague Miguel will be talking about later, so keep tuned for that. We'll move now into the feature extraction, and to start with, we all know that we can either extract from point clouds or from imagery. So these are the two main extraction methods. Extraction from point clouds relies on the coordinates of the points, but for images, it relies on the concepts of photogrammetry. Therefore, we need two images, which relies completely on the concepts of photogrammetry and stereo measurement from two different frames. In addition, we can also use a one-click measurement, which will need some help or some aiding reference planes or ground surface. Let's move into this and see what each point means. From point clouds, we can either pick a point, which simply we're picking the coordinates of a point, x, y, z, or by looking at the intensity values that are used by the semi-automated tools, then we can simply extract features. However, for the stereo measurements, we will need to have two images, both of them looking at the same object, and then we can start extracting. The requirements for this step is that you have to do the extraction in the same sequence, meaning if you're extracting a rectangle or a square, you have to do it counterclockwise from both images, keeping the same sequence of picking the vertices. In addition, it's important to know that the limitations of this extraction method is within the distance to your object, meaning further objects are going to be represented by less pixels, so you'll have more error margin. In addition to that, you have to keep in mind your parallax angle, which is simply the angle between the two measurements techniques. Meaning that if we have an object like the yellow square in the middle, we have to be sure that we're not picking from the next image, which is very close and will cause a very small parallax angle, but rather pick from a further image, which will give us a bigger parallax angle closer to 90 degrees. One more extraction method is at the reference planes intersection, which requires that you have reference planes that could be any vector file from a line or a polygon. The limitations for this method, again, lies within the distance to your object. So because we're extracting from images, of course, the further the objects, the less they're going to be represented by pixels. This method also works only on horizontal or vertical objects, so you cannot use it to extract any other orientations. One final extraction method is with ground surface, which basically assumes an infinite horizontal plane below your image position and will intersect every ray or every click that you do from an image with that horizontal infinite plane. Limitation for that is the measurement angle. So the further the object, the sharper the angle. And as we have seen before, the parallax angle will be very small for that. And also we have to take into account that objects that are further from my image are not at the same ground level as where my image was taken. Now we're gonna go into some hands-on and extraction inside TMX, and I will leave this to my colleague Miguel.
Thank you, Bishoy. So let's see how we can apply those concepts that we just saw into the feature extraction in TMX. I will be working now first with the MX7 data that Bishoy opened or added for us. And I will show you an example for extracting feature using forward intersection and ground surface. First, I like to change my coordinate system of my background map so I can work more easily. And before to start, I also need a vector data set. Let me call it my points. For this example, I will use points as a special data type, and the geometry type will be 3D. The same the coordinate system that we are going to store the features. And for now, I won't give any attribute in my vector file. Let me save it in my resources folder and make sure that it's activated, visible in both map view and the mobile mapping tab. So as we explained before, we need two images to extract a feature using the forward intersection. Now, if I'm interested to open the second one, I will have, two images looking at the same object, and we will have to validate or to have a beta heading values for fixing our parallax angle. So the farther we go, the farther we go, the closer the parallax angle. So, for example, if I'm interested to extract this feature, I will need to set first my preference measurement in the 3D hover technique. So I will start first with forward intersection. Then we will move to feature extraction, and I will use a single point. So as we mentioned, we need to use two measurements, one in one image and the second one in the second frame. First object extracted, next object, and I would like to extract two objects in the same method to show you the difference between forward intersection. Save it. Now allow me to change my measurement technique to ground surface when we will using only one image, and we can close for now this second image. Now I will extract a parallel line to the initial points using ground surface interface. And as you see, while I'm extracting and saving, the features are not placed correctly in my 2D map. The 2 points that you see in the 2D map are the initial 2 points that are extracted forward intersection, and the corresponding points that are extracted with the ground surface interface are placed wrongly. What is the reason for that? Let's have a look at how we can identify the problem. So if we measure first the distance between the 2 points that I just created with ground surface interface, the distance is around 60 centimeters, which in reality is not. What about the feature that I extracted with forward intersection? Is about reality 2 meters and 20 centimeters. So by measuring the difference in height of the two techniques, we can identify and see that there is a mismatching or a displacement in set value of 1.5 meters. This one could be an indicate that our camera height is not set up properly. If we navigate to the run that we just created for TMX, so Braunschweig MX7 data, we will have a look in the OMR file, and we will inspect the camera photo height that is there. So meaning camera height 50 centimeters, so the car was placed around 50 centimeters above the ground, which is not according with reality. The camera height should be something about 2 meters, something according with the installation parameter that you have in your car. Once we edit this value, we can come back to our TMX run, and to update this, we need to close the run and open it again. Now, if we focus in the feature that we extracted, still we see the difference between the two methods. But if I extract again the object using the correct camera height, we will have different results. First object extracted only with one click, second object extracted with the second click. Once it's saved, we see not only the right position in my 2D map, but if I have the measurement between the 2 points, I will have correct distance in horizontal height, no difference between set values, and if I compare the level of the two measurement techniques, will be 10 centimeters. That is close to the accuracy of our extraction. Well, this is one of the ways to extract feature using ground surface technique, and now I will show you an example to use vertical reference planes. For that, I will be using this reference file. This reference file allows me to extract in a faster way the facades of a building. So you might imagine that if I extract this feature using forward intersection, will be not only time consuming, but very tedious to fix the 2 images for each feature that I'm extracting. For that, I will switch to avoid this, I will use instead the reference planes intersection technique. By using this technique, I need to use this reference line as a footprint of the building. I need to activate it and make it visible in the mobile mapping tab, and then I will create a vector file called simply facades. In this case is area 3D, and I will be interested to store my areas by assigning a formula. The formula we are going to measure is area XYZ, and by saving the file, we are ready to go to the extraction. I activate my vector file to store the features, and now by using feature extraction, I will use any of the available functions to extract perfectly vertical elements in the facades, that I'm interested to. I'm not only saving the geometry, but also the attributes calculated automatically by the formula that I have. So using the vertical reference plane is a very good way to extract automatically and in a faster way features in your data using images. That is could be useful for MX7 users. So now let's move on to feature extraction for MX9.
All right, so after we've seen now how we extract features from the MX7 data, we're gonna move into some point clouds extraction. So I'll simply close my run here and I will navigate to my ready MX9 run that I've imported from before. So this run basically was captured in our city here of Bibra, and I'll be showing you today how we can extract features from the point cloud mainly. For that purpose, I'll switch to the 3D map and I will simply zoom to my point clouds and switch this to the black background so you could see easily what we're doing here. All right, so we should be ready now to start the extraction. So first of all, we will be showing you now how we can extract some lines, and then later we'll go into some semi-automated extraction tools that will help you save some time and effort. All right, so I will simply add a new vector data set, which will be also some lines of interest, keeping it simple, adding a attribute for my length, and I could use measure length or measure distance XYZ, or maybe I'll even use the object length. All right, so now I could be ready and we can start data extraction. So first of all, let's say we want to extract some lines representing the road markings or representing the pavement edges. I will switch my preferences now to the point cloud closest point, and I should have a smoother navigation at this moment. And I will simply start extracting some of these lines that we have here. Let me make sure that we are sitting in the correct area, and yes, we are. Looking very good. And then I will start simply extracting that line. And I will use first measurement, which is distance. Distance simply is a measurement that ends with 2 clicks, and then I could move to the next object and extract another one. However, if you're interested in extracting more, then we can go to the line measurement, which simply takes more input from you, like so. And now let's say while extracting, I made a mistake. You could simply right-click on the vertex, or even if the line is finished, like so, you can simply take the vertex and move it to fit somewhere else. And that's how you can edit features while you're still extracting them. And if you're not happy with this vertex, you can remove it still, or remove this one, or even add more in the middle. And once you're happy, you can just move to the next object. In order to delete this one, we can simply select it and delete it like so. All right, so now let's look at how we could extract some features with the semi-automated tools. So I will simply delete this line that we have here, and I have a very clear solid line that I would like to extract. And for that, I will be using the road marking with 2 clicks. The road marking with 2 clicks allows you to simply extract such a line with simply clicking at the beginning, giving a direction, and then simply you let the tool run, and then it will extract your whole line. So let's try this like so. Oops. All right, so I just got stuck for a moment. Let's try this again. All right, so as you see here, the green dots appearing, which means that I'm extracting my line. And as you see, it will just keep following and following and following until all the criteria is met, or something that is an object that has stopped it, or the intensity has maybe diminished. Once you're happy, you can go to the next object and then keep extracting. Next tool I'll be showing you is how to extract also road marking, but that time is not going to be a solid one, but rather a dashed one. The tool is also fairly simple. You can simply start by giving beginning and an end, and then the distance between the two of them. And as you see, the tool also still runs and then extracts my object nicely. And then I can move to the next object. Later, we want to move to extracting edges, and I will simply use the easy free line tool, and I will be interested in extracting the edge of the pavement here. So you might not see it very clearly, but let's see how this affects my extraction. So as long as I'm extracting that way, I don't know where is my edge, and it's not very clear for me or for my eyes where is the edge of my pavement, which means I could use some help from an aiding tool. And the tool that we want some help for is the hover. So the hover could simply snap to the ridge of the pavement, which helps you easily snap and quickly find your edge, like so. And now I'm sure 100% that this line is simply representing the ridge of my pavement. It's also very nice to combine this tool with the semi-automated curb extraction or ridge extraction with 1 point by simply letting this point run, and it will simply extract the ridge of your pavement, like so. And you can go to the next object. In addition, you could also use the multi-ridge tool, which simply lets you not only extract 1, but maybe also 2 ridges together, or even 3 of them. And let the tool run, and it will simply extract 3 lines representing your edge. Once you're happy with its extraction, we want to show you now another tool that helps you extract fences. So for fence extraction, the tool simply takes an easy input from you with 1 click, and we have here some nice fences as you see all over the place. So let's try with a fence like this one, and I will choose the fence extraction method, and I'll simply click, and there we go, the fence is extracted. And then I can simply move to the next one, also give it another click, and my fence is extracted. You have to be careful with this tool, because as you see here, there were some bushes that stopped the fence, or stopped the tool from continuing. But if we have a nice clear one like that, we can simply expect very good results. All right, so I will be switching now to another data set where I want to show you the railway extraction. So railway extraction requires, of course, that you have rail data. So I will simply switch from this one to another railway data. Switching my coordinate system to fit the new data. Zooming into the beginning of my rail, enabling my point cloud, and as you see here, I have some really nice railway data. All right, changing my preference method to, again, back to the closest point. Easier navigation, don't forget that. And simply the tool requires that you first have one line vector dataset that is active, extract objects, and I will choose the rail with 3 points. The tool simply takes from you 3 clicks, which means beginning, direction, and simply distance to the second rail. And let the tool run, and as you see, the tool will keep working and working and working until some of the criteria that is set in the preferences are not met. So this is quite a large data set, so we will stop this at this point and then move back to my BBRAC data set so we could continue with other topics of feature extraction.
Okay, so knowing those features, those tools to extract features from the point cloud, I would like to add 2 additional tools that will allow you to extract or localize more accurate features in the point cloud. 2 of them are the slice view and the clipping box. So I will start with the clipping box, and I like to use the clipping box to extract, for example, horizontal features like footprint. So the clipping box the slice view will allow me to navigate through the point cloud and see features that are somehow hidden in my dataset. So to define a slice view is needed only a click, and they will create a perfect slice horizontally to the ground. This is the benefit to extract features using the slice view, because you will have the same horizontal level for the extracted features, which could be very useful for the footprints of the building, especially for those buildings where the walls are not clear seen in the top view of the building. The navigation of the tool allows you to increase or decrease the size of your slide view with the mouse wheel, and also with the right click of the mouse, you can navigate through the footprint of the building that you are going to extract. So using already existing vector data, like we have allowed me to use the same as a facade. So I will extract a feature, and I will use free horizontal tool to extract a vector. I come back again to my slide view, and I can simply navigate and extract the footprint using my slice view. I can finish with double click, and as you see, the measurements are taken both in the 3D map and in the slice view. I can store this view, and let me then show you how to use the vertical way. I would like to select a nice facade. Maybe I can use this building here. So for example, extracting vertical information in a 3D environment could be a very not easy to navigate in. So we could also benefit to use a vertical slide view to have a clear data set for the extracted features. To define a vertical slide, you need to place the first point where the slide view will be located, and the second point will define the direction of your slide view. Same as the horizontal view, you could change the size or the location of the horizontal view, and then you can start the extraction of the building. You can also increase the thickness of the slide view to have a better definition of the facet, and once you have the facet seen in the slide view, you can start the extraction by using the available tools for your vector file. Difference here is that you won't see the measurements that you are extracting in the slide view, rather in the 3D map. So if I measure or I extract a feature in the slide view, I will be able to see it only in the 3D map. But the good of the tool is that you will extract perfect horizontal or vertical objects. Another tool that I mentioned at the beginning is the clipping box. The clipping box will allow me to extract features that are not seen easily in my data set. Let me navigate to a very good spot to use this tool, and I will use this area. So the clipping box will allow me to isolate data in the point cloud and focus only on a specific part of the dataset. So, sorry, I need to define again by distance, and I will focus in this area of my dataset. And I can make hidden the rest of the data and focus only in this part of the data, and also to see only this part of the dataset. So as you see here, we have we have 3 different poles that we could extract from this data set, and using the combination of the clipping box and the horizontal slide view, we can easily extract these features. So if you see in my slide view, you will have the chance to measure the radius of each pole by using the combination of the two. So let me switch to my vector point data. That should be my points. And now I will be able to use the center of the circle to extract the center of the pole and measuring the radius of this feature. So 3 clicks and I will be extracting perfectly the center of the pole, and we will have some additional attributes to store in my feature. I will save it and quickly start the second object, next object, and as you see, we will see the object that we are extracting once we finish with next object. Next object. Now, if we want to see the object, we can clear the box, activate the points, and move to the mobile mapping tool to see the extracted objects in my map. So we see 1, 2, and 3 objects extracted in a very fast way. So I think this is all for today. We will move now to the summary of today's webinar.
All right, so thank you, Miguel, for that. And I guess for now we have shown you enough of the software, and there is a lot of features to go, but let me summarize up what we have seen so far. So we've seen how we can simply export the data from TBC and choose the export options depending on the data type. We have seen how to import the data into TMX and take the template into account. And later we have seen some nice tools that could help you extract your features in a more efficient way. At this point, we'll be very happy to take your questions, and we'll have about 15 minutes for that. So we've already had a couple of questions during the session, and we will be answering all of them now. All right. So we have a question regarding for MX7 GeoEDIN TBC export is taken account, but it should not be used, right? So actually in the MX7, all of the export is done on ellipsoidal heights and on WGS84. Another question asking in Trident, it was possible to skip frames if you had a lot of panoramas taken to reduce the amount of panoramas. I haven't found something similar for that in TBC. Is it possible yet? Unfortunately, no, this is not possible. So the export will basically export or convert the whole PGR stream or MX IPS stream. So all of your data will be exported without any skipping. We're talking about images. For point clouds, you have multiple options to reduce the point cloud processing time or the point cloud amount, as you have seen before in the previous webinar on the filter settings. Yep, we have a note here that TBC 520 will be coming soon, very soon actually, and in that we can export or we can expect to export the point clouds with both RGB values and timestamps, which is currently with 511 not possible. All right, so something about the template and that it was a generic template was used and for a specific one. So of course, this is not a good idea. However, the template affects basically the planar cameras more or less. So this is where you will see difference or alignment between the point cloud and the planar cameras if you're using the wrong template. All right, more questions about photo camera height parameter in the OMR file. What's the reference point of the MX9 system to perform the measurement to? So it's the reference point or this photo camera height is taken from is always your image itself, which means the coordinates of your image is X, Y, Z, and then the photo camera height is simply adding an infinite plane below the Z of the image. And this is how it assumes an infinite plane just below the coordinates of your image. So the image is obviously will be floating above the ground because the camera is on the car, and then it will assume an infinite plane under your image at the photo camera height distance.
It's also good to mention, based on this question, I guess, is to know what is the reference point for the MX. So this camera height will be given by the installation height of the system on the car, measuring the height of the car to the reference point in the roof rack. Then the TMI will be calculate the proper camera height into your mission project.
Yeah, for sure. So, so this photo camera height should actually represent the distance between your ground and the center of your camera. So you either measure this manually yourself in the field, or you can take into account the lever arms between the reference point on the MX9 roof rack and the center of the camera. So both of them are possible. But the most important part is that you know that this distance represents ground to center of the camera, the ladybug, of course. A question, how to join the ridge lines at the corners and turnings. So the ridge lines can be joined either by simply drawing a line that fills the gap between two lines. So you could simply draw a line between them, or you can simply, from the 2D view, start manipulating your data with the CAD tools. Can we use the drafting methods for area point clouds? Yes, for sure. So these methods are available for any point cloud. They work on any point cloud, not just the mobile mapping. Another question, how can we extract traffic signal also? Yes, for sure. You can extract them manually just by placing a point there, or with the automated tools, which we'll be discussing at another webinar. So there will be another webinar for automatic tools, completely automatic, and then we'll be discussing more on the traffic signals and also the poles extraction. Is it possible to import cloud and panorama from an SX10? Yes, that is possible. So if you have any LAS file, you can simply drag drop the LAS file. However, with the template, we are simply preparing a mobile mapping run. And a mobile mapping run is specific for the mobile mapping systems.
So basically, importing the SX10 data, we will be able to use the measurement tools that we spent today for
Yes.
point cloud,
Yeah, exactly.
but no integrated with the mobile mapping data.
Exactly. This applied to GeoEd to the vector data. Yes, so you could measure in any coordinate system that you like, and then while you're exporting, so I personally prefer for now to use the UTM-Os, but when I'm exporting my features, I could choose to export them in any corresponding coordinate system of my choice. So this could be done either while you're creating the vector file itself, so you could create it in any coordinate system with GeoEd or with any height model that you like, or while you're exporting this data, you could choose to export it in a different coordinate system with GeoEd as well.
It's worth also to mention that the GeoE model is not defined by default in TMX, so the user need to define this GeoE model in the coordinate system of the software to be able to use it before to create a run or a vector file.
Yeah, that's correct. Do we need to classify ground while extracting features? No, and even if you classify ground in TBC, the classification is yes kept in the LAS files. However, TMX will not read the classification. So it's a feature on the list of improvements, but for now, TMX does not work on any classified point cloud. So it will be imported without any classification, without any regions. It will be understood as just one class. Is there any evaluation version of Asset Mapper Pro to know more about feature extraction? Yes, for sure. So as always, you can just send us an email to imaging_support and simply say that you want a license or a demo license, and we will be simply helping you with a license. So that's not a problem at all. Can we get MX software without hardware purchase? Yes, why not?
No, it's not allowed.
Is there any option to extract the wire in automatic or semi-automatic way? Yeah, we have some tools to extract catenary lines. However, they are very sensitive to the density of your data, the density of the point cloud, and how the lines or the wires were picked up by the scanner. You also have to process your data properly in TBC, taking into account that you have power lines, and we have already a profile for that into TBC filters. What is the minimum density of the point cloud, which is good to extract the features automatically? Well, I don't know how to give you a number on that, but it's a bit difficult. We usually use our scanners at the full maximum range and also the full maximum capacity, meaning we're recording 1 million points from each scanner, 250 rotations per second. This gives way too much points, but also for the feature extraction, the automated and the semi-automated, it's working perfectly fine, as you have seen from the demo. So this was just random data that we captured here. There was nothing specific. We just followed the same workflow as everybody would use, and the tools work perfectly. So of course, the denser the point cloud, the more precise these tools could work. Can we extract the poles and manholes automatically? For the poles, yes, there is automated tool for poles extraction. For manholes, no, there is nothing. So you have to pick them manually. All right, so any more questions? We have here a question which is a bit not clear for me, so maybe you could simply send me more clarification on this. So the question is about the vector data is automatically joined in TMX. So do you, Miguel, any idea?
I'm not sure about what that's join
so
meaning.
Maybe if you could just simply try to clarify the question so we could answer it.
Maybe just to mention that we have two kind of data in TMX. So one is the mobile mapping data coming from the system, and the vector will be separate from the mobile mapping data. So is vector will be separate if I understood well the question. So the vector could be separate from the mobile mapping data and could be independently exported. So meaning we could extract the features and move on to another software by exporting in DSF or chat file if it's needed. But if it's not the answer, please let us know.
All right, so we still have 5 minutes left on the webinar, so please send us your questions if you have any. All right, so it seems that we have no more questions. So we want to thank you very much for this, and we are very happy that that you're here with us today in this webinar. We're very happy to see lots of audience coming and joining. As usual, our email address for support and for any inquiries is imaging_support@trimble.com. So we'll be happy to receive your questions and answers on this, and we wish you all a very pleasant day and wish to see you in our next mobile mapping webinar.
Okay, thank you from my side and see you in the next webinar. Bye.